Now see, we will discuss some typical examples. These questions are shared by some of you. First question, a balloon rises from rest with a constant acceleration g by 8. A stone is released from it when it has risen to a height h, the time taken by the stone to reach the ground. Okay, see, a balloon is initially at rest on the ground. Okay, it starts from rest and moves with or moves vertically up with constant acceleration g by 8. When it is at a height h, what would be its velocity? Okay, let us apply v square equal to u square plus 2as. V square equal to u square plus 2as. See, initial velocity u equal to 0. See, we are applying this equation v square equal to u square plus 2as. Okay, initial velocity u equal to 0. Acceleration in the upward direction, it is given as, say, g by 8. Okay, so 2 g by 8 and the height or the displacement in the upward direction is h. So 2 g by 8 h. Okay, so this is gh by 4 and the velocity v1 will be root of that or root gh by 2. When a stone is released from a balloon which is going up with this much velocity, then the initial velocity of the stone will be same as the velocity of the balloon at that instant. If you are in a train, at any instant your velocity will be same as the velocity of the train. If you are traveling in a bus, your velocity at any instant will be the same as the velocity of the bus. If you are in a moving balloon, then your velocity will be the same as the velocity of the balloon at that instant. So, the person who releases the stone simply drops, he does not impart any velocity. So, as it is released from a balloon which is going up with a velocity root gh by 2, the initial velocity of the balloon, initial velocity of the stone will be same as the velocity of the balloon at that instant. It is root gh by 2 and that velocity is directed upwards because when the stone is released, the balloon was moving up. Okay, so initial velocity of the stone when it is released at a height h will be root gh by 2. See, once it loses contact with the balloon or once it is released, it will be moving under the effect of gravity alone. The only force acting on it is gravity. Or it will be just like a body thrown vertically up with a velocity root gh by 2 from a height h. So it goes initially it goes up and then comes down. Okay. When we take the displacement, you should not consider the path followed. Displacement is simply directed from the initial to the final. So that that stone has started its motion from here. Ultimately it reaches here. So the displacement is directed from this point to this point or downwards. Okay, and it is equal to h. So displacement h downwards. Throughout the motion, the acceleration is equal to acceleration due to gravity. It is also downwards. So we have initial velocity v1 upwards, acceleration g downwards, displacement h downwards. Now we want to find the time taken by the stone to reach the ground. Let us apply s equal to ut plus half at square. Okay, downward displacement h I have taken positive. So in that equation, initial velocity which is directed up should be taken as negative because we have chosen downward direction positive. The acceleration which is also directed down should be positive. Okay, g by 2 t square. Okay, see, to simplify this equation or for easy factorization, what you can do now, you have to make the coefficient of this quadratic term unity. How can you make this term unity? It is g by 2, you can make it unity by multiplying with 2 by g. Okay, while multiplying, you will have to multiply all the terms. So this will become 2h by g. Okay, when this term is multiplied with 2 by g, 2 and 2 will get cancelled. Okay, denominator there will be g, numerator root g. Numerator root g, denominator g. So it will be root g in the denominator and root h in the numerator. Okay, so it will be minus root h by gt. T square already here. Okay, this h when multiplied by 2 by g will become 2h by g. That is taken to the right, so it will be minus 2h by g. Okay, what remains on the left side? Only 0. Okay, so this will be the equation. Now for simplicity, let me replace this root h by g with alpha. Okay, root h by g is alpha. Then alpha square will be h by g. Okay, alpha square equal to h by g. And minus 2h by g will be minus 2 alpha square. So here it will be minus 2 alpha square and here it is minus alpha. Okay, so we have to get two factors. Their sum must be minus alpha and their product must be minus 2 alpha. Sum is minus alpha, negative. Product is minus 2 alpha square. If the product is negative, one of the factors must be plus and the other must be minus. Okay, if the sum is negative, okay, the higher factor or the larger factor or the bigger factor must be negative. So the two factors here are, their sum must be minus alpha and their product must be minus 2 alpha square. So the factors are minus 2 alpha and alpha. Okay, their sum will be minus 2 alpha plus alpha minus alpha. Their product will be minus 2 alpha square. Okay, so this can be factorized like t plus alpha into t minus 2 alpha equal to 0. Okay, if this product equal to 0, either the first factor is 0 or the second factor is 0 or both the factors are 0. If the first factor is 0, t equal to minus alpha, means t equal to minus root of h by g. If the second factor is 0, t equal to 2 alpha or 2 root of h by g. See, this t being a time interval, time can be negative, I have told you earlier, but time interval cannot be. Okay, so we have to go for this value t equals to root h by g. Now see, we have another beautiful example. A parachutist after bailing out falls 50 meters without friction. Means the first 50 meters is free fall, moving under the effect of gravity alone. At the end of that 50 meters, suppose the velocity is v1. Okay, so let us go for the equation v square equal to u square plus 2as. So v1 square equal to u0, u square 0. Then 2as, 2gh. H is given as 50 meter. Okay, here that h is h1, given as h1. That is equal to 50 meter. Okay, 2 into 50 will be 100, into 9.8 will be 980. Okay, then he opens the parachute. He starts decelerating. And finally, he lands with at the ground with a velocity 3 meters second raised minus 1. Initial velocity is given, final velocity is given. This deceleration also given 2 meters second raised minus 2. Now see, v2 square equal to v1 square, as it is decelerating minus 2a. Displacement is given as h2. Okay, here h2 will be v1 square minus v2 square over 2a. Okay, where a is the deceleration and it is given as 2 meters second raised minus 2. Okay, so 980 minus 3 square. Okay, it is 971 divided by 4. Okay, it is 242.75 or approximately 243. So this one is 243 and this is 50. So total will be 243 plus 50 means it will be 293 meter. Okay, so 293 meter. The height from where he falls. Okay. Now we have one more example, that is from variable acceleration. Okay, so the acceleration of a particle is increasing linearly with the time t as a equals bt, where b is a constant. The particle starts from the origin with an initial velocity v0. The distance travelled by the particle in time t will be. Acceleration is given as dv by dt equals bt. Okay, so velocity will be integral dv. Okay, integral dv means integral bt dt. Okay, b is a constant and the integral of t means integral of t raised to 1. It will be t square by 2. So b t square by 2. After integration, you will have to put a constant of integration always. Here it is c1. And that you can evaluate from the initial conditions. Okay, it is given that body starts with an initial velocity v0. Means when time equal to 0, velocity v equal to v0. When you put t equal to 0, you have to put v equal to v0. So V0 equals 0 plus C1 or C1 equal to V0. Okay, substitute the value of C1, that is V0, in this equation. So V will be Bt square by 2 plus V0. Okay, this is the instantaneous velocity and it can be represented as dx by dt, where x is the position. Okay, dx by dt, x is the position. Now dx by dt equal to b by 2 t square plus v0, and x will be the integral of this. Okay, x equal to b by 2, a constant, then integral of t square will be t raised to 2 plus 1 by 2 plus 1, means t cube by 3. And the integral of v0 will be v0t. Okay, and after integration you have to put the constant of integration, here it is c2. Okay, it is given that body starts from origin, means when time equal to 0, position x equal to 0. So when you put t equal to 0, you have to put x equal to 0. This will be 0, this will be 0, and this will be 0. Means C2 equal to 0. Okay, you can put that value of C2, that is equal to 0, in this equation to get x. So this will give you the position at any time t. Okay, as the body starts from the origin. Okay, this will give you the instantaneous distance traveled. Okay, suppose body starts from x equal to 0 and after say some time it is at x equal to 5. What is the distance traveled? It is 5 meter or 5 units. Okay, like that, this will give you the distance traveled in any time t. Okay, thank you.